All right, so this is just a video here. I'm going to cover a few questions on the midterm that I was asked about. Let me see. So I will do questions 2, 11, 13, 16, and 19 because you chances are that you're going to see a question similar to these on the final. So question number 2, it's saying that a state park charges $13 per day, or a fraction of a day, to rent a tent site, plus a fixed $4 park maintenance fee. And then so it says, let T of X represent the cost to stay in the tent for X days. And then they're asking us to find T of 4 1/3. So this question here, when you have T of X, you're looking at the fixed cost is going to be your $4. So then your variable cost is going to be $13 plus the $4 for my fixed cost. Now, the thing with this question, it says that it charges $13 per day, or a fraction of a day. So that means that if you rent it for half a day, then that's going to be the same as renting it for one full day. So then when you have T of 1/4, what you're really going to do is T of 5. So then T of 5 is going to be 13 times 5 plus 4. And so, again, one of the things that students tend to get wrong on this thing is that they don't round up. So even if you have 4 and 1/8 of a day, it's still going to be 5. So then for this one, it's going to be $69 the cost of renting it for 4 1/3, because that third basically becomes one full day. Okay, so let's go down to number 11. And so number 11 says, suppose the revenue from selling X radios is R of X is equal to 65X minus X squared divided by 10. And then use the function R prime to estimate the increase in revenue that will result from increasing production from 105 to 106 radios. And so for number 11, what we have to find, since R of X is equal to 65X minus X squared over 10, I'm going to rewrite this one as 65X minus 1/10 times X squared. And so since that's my function, R prime is going to be 16, right? And remember, if I have a power, right, so d of dx of that is, I'm going to subtract 1. I'm going to do 2x, and then so that's just going to be 2x, right? Sorry, let's just subtract 1. Which then becomes 65 minus x over 5, right? And so when I calculate this now, if I do, let's just say that it becomes, I'm sorry. So it just, at this point in time, they're saying from 105 to 106, right? And so if I do, the 105, so it's going to be, so R prime of 105 would be 65 minus 105 divided by 5. So 105 divided by 5 will give you 21, which is 61 minus 21. And so, 65 minus 21 is going to get you to 44. And so, when you increase it from 105 to 106, that would be simply an increase in revenue of $44. So that's the answer to number 11. All right. What's the next one? The next one is question 13. All right. So question 13, it says the price of a product is given by P of X is equal to 1,024 divided by X plus 900, where X represents the demand of the product. Find the rate of change of price when the demand is 2. So what they're asking us here is basically to find P prime of X. Right, so 1024, oops, sorry, let me rewrite P of X here real quick. So it's going to be 1 over X times 1024 plus 900. And so if we, in this case, we're going to find P prime of X. And so what we have to find is the derivative of 1 divided by X. And so when we do that, remember that we can take the constant. The constant 900 is going to go away if I'm going to find the derivative. And so we just have to find, again, like I said, the derivative of 1 over X, which is just going to be, so sorry, let me do P prime. So P prime of X is just going to be 1024 over X squared. And so here at this point in time, so number 11, let me go back to the, sorry, looking at the problems on the computer and it froze on me. Hold on a second here real quick. Let me go back to the problem so I can read number 11. So, let me get back. There you go, number 11. So when the demand is 2, so P prime of 2 is equal to negative 124 over 2 squared, which is negative 1024 over 4. Sorry, my computer froze and I couldn't go back and see the problem that I needed. So 1024 divided by 2, by 4. Sorry, 1024 divided by 4 is negative 256. So that's how you do number 13. The next one is number 16. So number 16 is saying that the total revenue from the sale of X stereos is given by R of X is equal to 4,000 times 1 minus X over 100 to the second power. And so when we do this one again, what we're going to do is we got to find, for this particular one, so it's asking us to find the marginal average revenue. And so what we're going to do with this particular problem is remember that the average revenue is the revenue divided by the quantity, right? And so what we have to do here, of course, is just find the derivative of the function that we have here, right? And when we do that, we get our answer. So if we work this out the way that we have it here, I can rewrite R of X. Actually, let me just find R prime. So then R bar prime of X is going to basically turn out to be 2 times X squared minus 1, 2, 3 over 5x squared. And so that turns out to be your answer for that given question. So that's r bar prime of x. And so the next thing that they're asking us is we can actually break this down a little bit more. And so we basically can end up with, we can, multiply here by 2/5, and then so that I believe that the answer that you have in the textbook, or the, sorry, it's not negative. So you end up with the following. And so that's the answer to number 16. So number 16 is basically just, what I could have done here if to d of dx, 4,000 times 1 minus x over 700. Hold on a second here. I think I calculated it as 100. Yeah, I wrote 100 there, which is not the correct question. The correct question was over 700. And so I have to fix that here real quick. I apologize for that. I wrote that thing wrong. So it's going to be 2 times x squared minus 4 over 245 x squared, which will give us our final answer of 0.008 minus 4,000 over x squared. So if we clean this thing up, I get 2x squared minus, so if I multiply 49,000 times 2, not 49,000, I got four zeros. 1, 2, 3, 4 times 2, I get over 245 x squared. And then so when I divide that, so let me separate it here a little bit more so you guys can see it. So 2x squared over 245x squared minus 980,000 over 245x squared. This is where you get the 0.008 minus the 4,000 over x squared. So in this case, you can use the chain rule, right? And then multiply that times, right? So if I use the chain rule, f of x would be x squared, g of x would be 1 minus x over 100. And so remember that then d of dx is f prime of g of x times g prime of x, basically. And then so for this one, this is just 1 over 100. So that just be, the negative x squared over 100, basically, for that one. And so that's what you do to find the chain rule for number 16. I mean, the answer to number 16. And then the last one is number 19. And it says, suppose the demand function for x units of a certain item is P is equal to natural log of x plus 5 over x, where P is the price per unit in dollars. Find the marginal revenue. So what happens here is that we know that R of x is equal to quantity times the price. And so what we can do here is we can basically multiply that by x, right? So x times p is going to be equal natural log of x plus 5 over x, which is going to be 100x plus 180 natural log of x plus 5. Right? If I multiply that to find the revenue function. So now, since that's my since this is my revenue function, if I'm just finding the marginal revenue, I'm just finding r prime of x. So then 100, the derivative of 100x is just 100. Now remember that the derivative of the natural log of g of x is just g prime of x over g of x, right? And so for this one, it's just going to be, so remember, the derivative of x plus 5, the ds of x plus 5 is just going to be 1, right? So this becomes 180 over 1 plus x plus 5, which is 100 plus 180 over x plus 5. And so that's the answer to number 19, number 16, number 13, number 11, and number 2. Thank you.